Looking at section 5.3, part 2, we're going to start by looking at the power reducing formulas. These are located on the trig cheat sheet in the upper right-hand corner. You'll see a spot that has a title of half angle formulas. And then next to it, it has an alternative or alternate form. And if you look under the alternate form, that is where you're going to see the sine squared of theta, the cosine squared of theta, and the tangent squared of theta. And the variation on the yellow paper compared to what the textbook shows are very similar. So they have the sine squared of theta is equal to, and in this case, it has a 1 minus cosine 2 theta divided by 2. Now, the one on the formula sheet says a 1/2 times a 1 minus the cosine, and they put that 2 theta in parentheses. All they're doing is taking this divide by 2 out to the front and calling it that 1/2. Same thing with the cosine squared of theta. The formula sheet says that it's a 1/2 times the 1 plus the cosine of the 2 theta. So just some minor variations to those, but that is where they're located on your formula sheet. So we're going to look at using those today. So for example, it says reducing the power of a trigonometric function. It wants us to write an equivalent expression for sine 4 of x, or sine to the 4th power, or sine x to the 4th. That does not contain powers of trigonometric functions greater than 1. So our goal is to simplify this all the way down so we have no more exponents. So if we have a sine of x to the 4th, technically, sine 4 of x. That means we want to start by breaking this down into, if I have a 4th power, I can break this into a squared, sine squared of x, but call that a squared, because a squared is a 4th power. Now, if I have a sine squared x, we can take this and replace that with a 1 minus. We're just going to go right up here. So if I have my sine squared, I'm going to replace it with this piece, 1 minus cosine of 2 theta divided by 2. So I'm going to have a 1 minus the cosine of 2 theta, although we don't have theta, we have x. 2x divided by 2, and that's going to be squared. Now I have some squared, so I'm going to take that top piece and I'm going to square double square it. So if I square double square it, I'm going to have a 1 to the 2nd power, which is 1. And I'm going to have 1 minus cosine of 2x doubled is going to give me a minus 2 cosine of 2x. And then I have the minus cosine 2x squared, so then I'm going to end up with a positive cosine squared of 2x. And that's all over top of, I have a 2 on the bottom to the 2nd power, so I'm going to have a 4 on the bottom. Well, I'm not quite there yet because I can't have anything greater than 1 as an exponent, and we still have this cosine squared of 2x. So now we need to go and break that piece down. Before I do that, I'm going to take this 1/4, and if we want, we can take that whole thing to the very front, or I can start breaking this into pieces. So I'm going to break them into pieces. This is going to equal, if I have this 1 that divides by 4, I'm going to have a 1/4. Next, I have a minus. I have this 2 cosine of 2x that's going to divide by 4. So I'm going to have a 2 cosine of 2x that divides by 4. Although if I have a 2 on the top and a 4 on the bottom, isn't that the same thing as a 1/2? So I'm going to take and get rid of this and call this a 1/2 of cosine of 2x. I'm going to drop that down just a little bit. And then I take my next piece. I have a plus the cosine squared of 2x. And so I'm dividing that piece by 4. So that means I'm going to have a positive 1/4 multiplied with this cosine squared of 2x. So all I did is I went ahead and I broke those into pieces. My 1/4 is going to stay as it is. There's no power greater than 1. That 1/2 cosine of 2x is done for right now. We have a plus the 1/4 times that cosine squared of 2x. So that's going to be the next piece we break down. So if I have this cosine squared of 2x, again, we're going to go use one of our new pieces. We're going to use this 1 plus the cosine of 2 theta divided by 2, but in our case we have x. Now this is where it's tricky because we are going to take a 2 times whatever theta is. In this case, our theta is a 2x. So when I take a 2 theta, I'm really taking a 2 times a 2x, which means I'm going to end up with a 4x in this piece. So this 1/4 just kind of carries in the front. And then I'm going to take this cosine squared of 2x, and I'm going to rewrite that as my 1 plus cosine of 2 theta, we said is going to be a 4x. And that's going to divide by 2. And I have all the same stuff that's going to keep dropping down. You can rewrite it if you'd like. I'll do that just so I don't lose it. All right, so we got rid of all the powers, but I still have some ugly fractions going on here. So let's go ahead and simplify some of this out. Now, if I'm having a divide by 2 here, and I have a 1/4 on the outside, that's the same thing as saying I have a 1/8 times this 1 plus cosine of 4x. So then I can distribute out this 1/8. So I'm going to have a positive 1/8 added with a 1/8 of cosine of 4x. And then all of this other stuff is just going to drop right down. I have a 1/4 minus a 1/2 cosine of 2x. And let's see, do we have any like terms that we can start combining? Well, I have a plain fraction 1/4 and I have a plain fraction 1/8. And if I have a 1/4 plus 1/8, that means I have a 2/8 plus 1/8, which is a 3/8. I can't combine that cosine 2x and cosine 4x because they're completely different pieces. So I'm going to have a minus 1/2 of cosine 2x and a plus 1/8 of cosine 4x. I don't have any powers greater than 1, and all of my like terms have been combined. The next piece we're going to look at is those half angle formulas. And as I mentioned, it's on that top right-hand corner of that yellow paper, that formula sheet, the trig cheat sheet. So that tells us we have the sine of alpha divided by 2 is equal to the plus or minus the square root of 1 minus cosine of alpha divided by 2. Our cosine of alpha divided by 2 is equal to plus or minus the square root of 1 plus cosine of alpha divided by 2. And our tangent of alpha divided by 2 is equal to plus or minus the square root of 1 minus cosine of alpha divided by 1 plus cosine of alpha. So it tells us that the plus or minus symbol in each formula does not mean that there are two possible values for each function. Instead, that plus or minus indicates that you must determine the sign of the trigonometric function. Is it a positive or is it a negative based on the quadrant in which the half angle lies? So this positive or negative is going to be based on the quadrant in which that half angle lies. So it's not positive or negative in the sense of plus or minus. It's you have to determine which one it's going to be. Let's try an example. So it says using the half angle formula to find an exact value. So they tell us to use the cosine of 210 degrees is equal to a negative root 3 over 2 to find the exact value of cosine of 105 degrees. So if I have the cosine of 105, how did they figure out how to make it into a cosine of 210? If we are dealing with half degrees, you have to think of a cosine of 105 is equal to the cosine of what divided by 2. All right, that's where this 210 comes from. And then the cosine of 210, you find that off of your unit circle. So let's take our cosine of 105 degrees. We're going to set that up as our cosine of 210 divided by 2. That's what it's equivalent to. And then we're going to go about using our function. So if we were to go back up here, we're using our cosine piece. And if we have 105 degrees, what type of sine are we going to need? So if we're at 105 degrees means that we are going to be in quadrant number 2, right? We're in quadrant 2. And if we're in quadrant 2, and we're dealing with a cosine value, that means we're going to end up needing the negative version, right? Because cosine is our x value, and our x is going to be a negative value in quadrant 2. So as we go about setting this up, we're going to need the negative portion of that square root. And we're going to have 1 plus the cosine of our alpha, which is just at 210, divided by 2. When we simplify this down, we're going to have a negative, and I have a 1 plus cosine of 210 is going to give us that negative root 3 over 2. So it's going to be a negative root 3 over 2, and then that's divided by a 2. Do a little bit of not so fun fraction work. Let's see what we got. If I have a 1 plus a negative root 3 over 2. We need to get rid of fractions and fractions. So if I multiply by a 2 over 2, I'm going to end up with a 2. This 2 cancels that 2 to give us a minus root 3. And this 2 times this 2 is going to give us a 4. Now that's still inside of that square root, which means I need to simplify this down a little bit. We're going to end up with a negative square root on the top, 2 minus the root 3. And then on the bottom, because I'm taking a square root of 4, that's going to give us a 2. And there's nothing else I can do to finish up that final answer. And the very last piece that we're going to look at is those half-angle formulas for tangent. Again, on your formula sheet, they give you this first, which one do they give you? They don't give you either of those two variations. They just give you that initial variation. So this might be something you want to add onto your formula sheet. You can kind of add it up in that upper right-hand corner. There's a little bit of room. So some other variations for the half-angle formula for tangent. They have tangent of alpha divided by 2 is equal to the 1 minus cosine of alpha divided by the sine of alpha. And then the tangent of alpha divided by 2 is equal to a sine of alpha divided by 1 plus the cosine of alpha.